Good afternoon, ladies and gentlemen. Again, Engineer Michael Chola is back. We continue to share our experience. You know, this is very important. I would appreciate if young engineers and those interested pick up interest to follow and pick a few points here. This time I'm going to talk about the genesis of emergency repair of Karuma Bridge, which started way back May 2024 to December 2024. May is known for the observations of that structural defect that went viral, then which informed the genesis to see how to urgently repair the bridge. But in brief, Karuma Bridge, 1964 to 24, major strengthening. Karuma Bridge is a steel concrete composite bridge. It has concrete deck and then structural steel members which are bearing the concrete deck on which the traffic move. It's a three-span bridge of 20, 48.8 and 16 meters, giving a total of 84.8 meters long bridge. The bridge comprises of two main steel plate girders and two number deck stringers and cross frames that tend to stabilize and give stability to the deck system. The bridge is located on an S-curve. This is the most interesting part of it, of Karuma Bridge. You see the Kampala site coming, you turn with a super elevation into the bridge. As you are getting out, coming to Gulu side, you're on super elevation heading to Gulu. When you're coming from Gulu side or Noya, super elevation. Now, normally where the bus is, trucks lose control here and then definitely get into the water and there they go. The challenge with the Gulu side is that the slope is more than 4%, which is very detrimental to big trucks. Because big trucks normally they are overloaded and sometimes they lose brakes, and that's how things happen and fatality is resisted. We have over 10 trucks which have sunk and disappeared under this bridge with no trace, except one last year, articulated semi-trailer that disappeared but was again reappeared. So that is what is happening. The S-curve nature gave it a complexity of this location, and normally it is very difficult to explain that. Major rehabilitation of the bridge happened in 2012, which was informed by studies done by Gulf engineers or Gulf consultant in 2009. So what we witness today is not the first time. Government has been trying very well to look after this bridge. Remember, the longevity of bridges depend on the maintenance. So government has not been sleeping. Right up from the Ministry of Works time, before handing over projects to RAFO and UNRWA, they were tending to this bridge. But majorly now is what happened in these last 3, 4, 5 months. So a major repair was, a minor repair was done, rehabilitation was done 2012. And then from there, the bridge continued to perform with minor touch-up here when accident happened. Approach roads were worked on, and also the gabion boxes also constructed because this site started collapsing. So those are the things. But again, government did not sleep. If you were keen, in 2012, 2014, government engaged a consultant from Italy called AIC Progetti, who designed for us a cable-stayed bridge across River Nile at that location, but a bit downstream of about 500 meters downstream of the existing. This bridge symbolizes a local instrument which unites most of the northern and west Nile people, what we call the local guitar, Adungu, locally, traditionally known, Adungu. And so it was a one support system, tall tower with so many strings, what we call the cables. So it was exactly symbolizing that. Unfortunately, government didn't have money, and so it was never constructed. it was expensive, about $70 million. So when in 2018 Japan government expressed interest through the ambassador, and they visited site with our ED in 2018, it is from that time that JICA picked up that interest, started refining, looking at the project options of funding and the rest of it. So they zeroed down on grant. So they are going to fund the construction of a new bridge. Well, they modified it after. They did an environmental assessment. They look at option assessment, scheme appraisal. They adjusted what was then has been reduced to what we call extra dose bridge, and location is brought closer to the existing bridge now. The other one was farther down, but now this has been brought. Japan is very sensitive when it comes to environment. The bridge location is in a very sensitive ecosystem, whereby you have communication with the wildlife, you have environment, you have forests, you have water bodies, freshwater bodies, and settlement communities. So Japan tried. Actually, they just favored this project. They were supposed to disqualify it. They just favored because of the friendship between the two countries. So they are allowed to really put it closer to what we have, so that it minimizes destruction to environment. So that is now what is happening. We hope the design commences mid next year, and mid 2026 we shall witness the groundbreaking for the construction of the new bridge. Is a 240-meter span bridge. Half of it is the normal PC box girder balance cantilever bridge, and the other half on the north side is what they call the extra dose. So during the opening of this bridge, the Minister of State for Works mentioned that a bridge similar to the Nile in the construction approach and methodologies, because all the supports are not in water, they are out. So you're going to do what they call you construct and keep sliding formwork from up as you see water down until the two sides meet, and you never have any props for formwork scaffolding into the water. Then the towers are not as tall as the one of Nile Bridge. This is slightly, so it's only 15 meters. The Nile is 69 meters. So that is the difference we have. This is a normal, it's an extra dose combined with the PC box girder balance cantilever, while the Nile Bridge is cable stayed single plane cable stayed bridge, single plane cable stayed box girder bridge, with the towers, two towers standing, or pylon, we call them pylons, basically 69, in total about 70 meters. So basically that's a briefly about the new Karuma versus the Nile Bridge. As JICA continued to do their appraisal, pre-feasibility, preparatory survey to see how best to get the grant scheme fitting within the taxpayers' money portion that they're giving government of Uganda, UNRWA also engaged MBW to do a diagnostic study in 2023. Because of sometimes people don't understand where things start from. Because of the frequent collapse or frequent accidents on the bridge, in one of the TMT meetings of UNRWA, I don't attend that. Me, I'm a middle line manager. But when we were there, that guidance to start the process, we were told that in one of the meetings, our ED asked a question about what is the lifespan of this bridge? What is the remaining life? I think the worry was, with this frequent collapse, don't you think this thing can actually end up with a disaster? So that question from the ED culminated into the study, and up to now today you see a replacement. You can now see how a simple statement can result into something that is beneficial to mankind. So our question propelled us to get deeper into our thinking, technical, and get to the root cause and follow it up. So when a consultant was brought on board, we came up with the term of reference. We put the thing, initiated procurement, and procurement was triggered. And our procurement department got the consultant. Contracts were placed. We managed the process. So in May, that is when the contractor had already prepared all the platform for inspection. We all went there, they went there, they look at the things. After inspecting, that's when we observed that actually they're on the Kampala side. Anytime that thing, if it was not because of reinforcement cage, which are all clocked together, that area, those car tires would have punched through and a vehicle would have gotten stuck on the bridge. But the good thing is that normally reinforcement tend to help, because reinforcements have been introduced in concrete because of their high tensile nature. While concrete is weak in tension, reinforcement come in handy to reinforce concrete in that area, that weak area. So because of that, this bridge remained vibrating but also standing and allowing trucks to cross. So we identified the cracks. When the cracks were identified, the consultant was told to give us the term of reference, the scoping, which they prepared immediately. We flagged it up to management, and they allowed us to move faster than the way the consultant would, because the study of the consultant was still waiting for other things, which it would have actually, up to now, it would not have started this repair that has been concluded. So thank God that the consultant was brought on board and they prepared a platform. And you also saw by yourself that during that time they had those mobile crane, the crane they were using to lower people. So at least you saw the activity. So no one can deceive you. Consultant played a bigger role in identifying this, whatever we witnessed on the 20th of December. So the journey to do emergency repair started now in May 2024. So once the consultant did their work, we proceeded also and got the contractor. By July, I think contractor was got on board, and immediately they were taken to site and they started. The contractor is China Railway 7th Group, together in joint venture with National Enterprise Corporation, I think NEC, the engineering brigade wing of UPDF. They did a good job. The most notable day was on the 21st of November, when I went to site in the morning. I left around 7 p.m. Concrete was supplied non-stop, casting concrete for almost 80 meters non-stop, and finished. It was very, very important, very, very appreciative. These are local contractors, local people working, and that's when the issue of local content aspect was very. So I realized that when there is resources, nothing is impossible. People were praising that government can do work, can finish within time. If now next time they should not deceive, they should be able to complete. Let me tell you, gentlemen and ladies, if the resources are there, you will always hit the project and even save time and even save cost. All you need is project implementation is 100% inch on available resources, resource mobilization, timely resource mobilization, and other things. So that is what you witnessed here. The contractor had capacity, even if government delayed to pay, but they had capacity. So that is how the commissioning on 20th December happened. It happened when many things in the kitchen were done. So now what happened is the opening of this traffic has been limited to smaller trucks. Actually, it's because, one, our traffic volume is not as high as those Western world traffic. It will not be accepted. But our bridge receives a truck at a time, So the load intensity is not so much drastic to worry. Number two, limitations. You normally, when you look at most road projects where you have bridges, a bridge is completed before the road. So by the time they commission the road, a bridge has already lasted for over even 100 days. You get it? So We normally don't realize that, but here, why we are limiting the bridge to the smaller track is that after 28 days, there is what we call healing process in concrete. As heat of hydration begin to decelerate, the cracks that were formed during the reactions, high heat of generation in concrete, heat generation in concrete, there is also loss of water, creating capillary pores, cracks, and other things. So water, you find as water get out of concrete, it leaves. So now after 28, you have reactions happening, but at a decelerated rate. Now that is when cracks and pores are getting closed to give you that density that you had assumed in your design, and to give the longevity and the capacity of the bridge. So you find that if you open the bridge immediately to traffic at that point, then because of deformation happening and bending, definitely you may disorganize the healing process and the closure of the pores. So it is okay that we allow lighter traffic that don't generate too much bending in concrete, so that in this period, within a month again, you will find that this concrete has actually gained proper capacity, in that all the pores could be now, like maybe 90 to 95% of all the pores and cracks have been now sealed or healed during this period. So because heavy traffic generates a bit of higher stresses, so that's why it is being left. And then secondly, because of expansion joint is basically, like explained, is more for contraction expansion, but still it should be able to withstand the weight of the axial load. So if you leave it, you allow heavy traffic to pass on, definitely it can disorganize it, it can break the edges and become difficult to fit. So that is why they're saying, let's first fix the expansion joint, and then also concrete will have gone by another now 60 days, and therefore it comfortably can be used. That is the limitation to the traffic that we had. This is something we needed to also know. What normally goes on behind the scene? What normally happens in the kitchen? Before we begin seeing flag bearers moving up and down, when people move, people begin to talk. We only see contractors and contractors team. We only see project supervision team. You only see other key stakeholders. But by the time contractors begin to run up and down, something already happened. So you find that from the time the bridge was identified to have defects, the technical experts had to converge in UNRWA to begin discussing how do we go about this. That is how you see MBW team came to the office, and the issue on the solution started, and this is where the demand and the request for the scope and what need to be done was made. It was on the 10th of May that a meeting was held. Our senior Batumba Patrick was the one trying to guide the whole thing. We were there trying to also see how best to handle the matter, and this was also followed with a lot of brainstorming, argument, what need to be done. The first solution was to have the bridge repaired, cracks sealed, and then that is why it was a 3-month thing. And many people keep asking, we changed the goalpost. No, the 3 months was stuck to repairs of identified cracks, sealing cracks that were also seen, and then painting torquing the loose ball, removal and replacing of corroded structural steel members, and then painting it, and then putting asphalt back, and then the bridge would be continuing. But that changed as soon as the contractor started. So that is why, again, you see the timing was a bit zigzagging. Now, this is now where they were trying to see, you see Mzee here is trying to demonstrate some kind of, the body language can hear, is speaking volume here. It is very important. So MD explaining the bridge response and effects on the failed section, bridge and instruction especially interjects on the explanation and seek clarification from the senior. So brainstorming session happened, like I think for almost 2 days. So here was that this was the worst defect that was observed. As you can see here, we are trying to explain now. This member here projects 0.6 meters away, and so the wheel tracks runs here, and this becomes like a cantilever. The main body is hidden here. So this is not the case with the guru side. The guru side was a vibration of elastomeric bearing, but this was not exposed like this. This one is acting as a small cantilever. So every time a wheel load is here, it is deformed downward. It goes back, deformed downward. So that exacerbation over the years created all these cracks, and that is why, after observation, it really created an alarming situation. But of course, to handle. So this is what happened behind the scene. We normally don't see it. People in the kitchen are never recognized. They don't see. You only see people serving. So these are now follow-up. We had to go down there, and after the platform was prepared, we had to go down there and have a look and to see what is actually happening. If you see this is the main girder, and definitely from the look, it looks okay, but some areas had some rusts and corrosion that will be handled. Loose bolts also will be handled. So these are when you are under the bridge, this is what will be seen. Of course, these slabs have been replaced. These stringers are all there. This is a stringer, this is a stringer. So this slab bears on the main outer girder and two other inner girders, you can see. This is the one inner girder, this is the second one, all spaced at 2 meters. So that is this is the thing that is bearing. While this cross frame carries the weight of this stringer, the deck takes the weight onto the stringer. From the stringer comes to this cross frame, then the cross frame take it to the outer main deep girders. So that is exactly what you look at. So it is key that these structural steel members are retrofitted. Ladies and gentlemen, the bridge is a bridge not because of the deck we completed. What they commissioned on the 20th is a riding surface. It has a local effect, but it takes its weight onto this one. These are the members that carry weight and give and take. So the load path is the deck, the vehicle exert loads on the deck, the concrete exert the loads onto the stringers and the outer girder, and the outer girders takes the load onto the pier support system and abutment, and this abutment takes the load now where to? The foundation. That is why if water level could go down properly, this repair work is supposed to continue. It was designed in such a way that you handle the deck system, come and handle the structural steel system, and go improve the bearing system, get down to the pier support, go down to foundation. Because now if you look at there are few loading that have been added on the deck system, lighting poles, even the density of concrete today is different from the density of concrete in 1960s. So though the replacement was verbatim the exact dimension, which is okay, but reinforcement cage change. Then they were using mile bars. The tonnage per linear meter is different from the tonnage today of the rig bars. So the weight in a way, but the good news is that with our mathematical checks, these girders are conservatively constructed here. I think they were used for some serious military tankers and other loading in the UK and then brought to Uganda, because a 2.5 meter depth girder cannot be placed over 16 meter span and 20 meter span. Over 16 meter span and 20 meter span, maximum is 0.9 meter depth, including the deck slab. This one with the deck slab is almost 3 meters. So all we need is to maintain this to avoid defects going beyond limits. Once we can do that, this bridge can take some time. The biggest problem with this bridge is the narrowness. So if that can be improved on the new one, I think that will be good enough. So these were some of the works behind the scenes. And no one talks about it. No one mentioned, even if you're in a rally. That is what sometimes perturbs people's mind. So after all this brainstorming and everything done, procurement, contractor gets into the ground. This is now where we see engineering. Engineering is not the mathematics and the model you do. It is this one here. This is when they know, work has started. And work started. The milling was done to pave way for them to plan on how do you systematically remove the concrete from the... Our worry was that we thought this concrete slab was compositely connected to the steel plate girders. But when they started, we discovered it wasn't. It's non-composite. So this slab basically rests on the concrete and allowed to. That's why we have expansion joint in between. It allows the concrete can slide on the slightly, can breathe in and out due to high and low temperature. So that's why the removal became. If it was not, we would have gotten into some other risk again. But we were so lucky that it was non-composite and became very easy to, as you can see. The first attempt made by the contractor, which could have led to other defects on the bridge, was to use jackhammers, but that was quickly managed by the resident engineer and his deputy resident engineer, because the effect was causing vibration because of these balls and also the frame connectivity. We just said no, let's not proceed. So they stopped that, and then they went ahead and they made use of cutting discs, which is more scientific with some extra care. So the only care which was the due care made here was to make sure they excavate along the steel plate girder top flange to expose it, so that when they're cutting, they know that they don't cut the steel that was going to be reused for this kind of work. So that was successfully done, and no such steel was cut. So that is what happened. The contractor commenced now cutting this using now this system, and they successfully did it very well. You can see here now the manual team and the jacking would be used along this, and then this crosswise is now to define the panel that could be safely lifted using crane and the belt, safety belt, put it up and then transported to the final disposal ground. So these are things that happen. Then one observation here, this is the bearing that was causing a lot of vibration and deformation when trucks were on it on the Gulu side. You see a gap here was about 10 millimeters. So whenever trucks would come, it goes down and up, down and up, down and up. So that in a way also created other effect on the pier support and other area where the decks are connected to, and created cracks. So after that, a design check was made. New bearings were ordered by the contractor from manufacturer. Manufacturer communicated for some clarification that we gave back, and they share with us now. This is the modern one, the new one, without any extra. So this is what they came and put. So with good maintenance and good follow-up inspection and cleaning all the surface, these things should work very well, and then and we should be able to follow the project and make sure it is durable up to the time when we get a new bridge. So existing bearing had holding down bolts for stability control and also controlling the uplift due to effect of loads in the middle of span. Yeah, from our model we discovered that even that holding down bolt tend to, because if you have a 16-meter span and a 20-meter span, outer spans, and the middle one is 48, almost twice. It means when you load the middle one, the bending effect there tends to lift those two end support. So you must hold the two end support permanently, not to move up. Otherwise, it will cause problem. So the bolts are serving two purposes. One is to hold down the girders and also keep the stability on the bearing. Actually, as revealed, it's not actually near there. It is actually further here. So very important. Even under self-weight alone, that thing tends to lift up. So we got to learn about it during that, and we try to make sure it is restored the way it is. These bearings, their maintenance-free life is about 20 years, and then they can be replaced. Here, the formwork teams the carpenter guys were trying to work on the support now to work on the overhang of this girder. It's about 1.07 meter off this main girder. So they were now trying to construct the scaffolding here so that this formwork extends and you have concrete being done exactly as per the original one. So they were working on that thing, and you can see the safety belt. The issue of safety was looked after well, though our worry was that we needed those side rails to be there to prevent people falling off, but no fatality was registered here. They worked very well, carefully, but we raised a lot of noise about it. These are technician preparing ISO PPE, safety belt. This was now when they had done all the formwork for this one, and now they were working on the outer one. So this is now the new, this was now the beginning of reinforcement works, and then formwork on the deck when they are replaced. So as you can see, the top of these girders are all flashing, nothing like shear connectors. So that one define a non-composite behavior of this bridge. These hooks they were putting is for them putting safety railing going through, and then they tie their safety belt on. That is what you see. They are not shear connectors. So here, this was not the time for concrete. From left to right, you have bridge specialists, bridge and structure specialist, Godwin Bajuka. Here is Lawrence Parillo, is the head of bridges and structures in the Directorate of Roads and Bridges, in charge of construction section. And then here is Godwin is in the design department, and Parillo in construction section department. And then you have Mr. John here is the contractor. When the first time we observed and we took the contractor to do the inspection, he was the first because he works with CRSB and with NEC. So we went down and took the video and saw all those bearings, and so he followed the project. And myself, I'm here, Michael Chol is here, a bridge and structure specialist and also team leader of the unit, but we handle design aspect and supervision with Godwin, and Dennis Opige is our bridge and structures engineer. He's the main brain behind this, has been doing all the works, and director also told him he has been full-time on site following all this reinforcement, tying everything. You see even he's having a bending staff here with him. Then this is our clerk of works on the yonder side. This, and I think concrete already started, and this is the setup that was done by the contractor. As you can see, it is this is the pipe of the pump. They are putting it on the used tires, and yeah, this was on the 21st of November 2024. This was done when they had done the setup, and the works was going to start from the other side, coming this side. That is the Gulu side. Casting, the supply is on this side. So they started from far end, coming this side. So this is now the concrete pump. So it was a very good technique. As you pour concrete, you transport concrete, you keep removing this member here from this joint as you come this side up to this point. From 8 in the morning up to 10 in the night, concrete was done. Constant supply. Very, very interesting. And it was ready mixed concrete. They were checking quality checks during workability of concrete checks. We were there checking the slump testing, the slump depth, consistency, everything. Those were all checked. And basically the young ones, they are aware of what they were doing. So this is now basically when it was almost coming to about 4 or 5 in the evening. You can see how far they had moved. That far end now that been left, they were already here. So that was the work that the contractor did that day, and entered into the night. By 7:15, 7:20, when we were leaving, this is where they were. It was basically about like 6 to 10 meters left. And by 10:30, we were informed concrete work was done. This is a mistake. This is 10 p.m. This is 10 p.m. not a what? This is 10 p.m. not 100. Sorry. $10 p.m. is here. Yeah. So, and working at night, there are challenges, of course. You can see this fly is here. And also sitting at this point, if someone just drops off, there are so many safety concerns when you're working at night. But sometimes you pray. At the end of it all, they always say, glory be to God. Everything is done by being guided by God the Father. So, if you have someone with ill intention to push someone in water where you can't see, you can push someone. and you never know. But thank God nothing like that happened. And but working at night, normally you work, but it has a little bit of a risk margin is slightly high. So this is what happened, and up to now we are not hearing any problem, anything that happened. No. So you know very well in projects implementation we have key stakeholders, we have issues to do with risks, we have issues to do with stakeholder management, communications, you have monitoring, you have challenges and the rest. So here is our Minister of State for Works. He came to visit the site. That day he was also heading to Pakwach. That's how we were also heading to Pakwach to explain what was there with the hydrology team. So he came around, we took him through, and this being the design that we have made, we are comfortable with the functionality and the behavior of the bridge. We had to explain to him what was happening, and then the Deputy RIE, that is Bongamin Charles, explained to him the progress, challenges, and their target. The good thing is the project implementation was closely monitored by the resident engineer and his team, deputized by resident engineer Bongo, the deputy engineer Bongamin Charles. And with support from our team, engineer Dennis Opige, who was following each and everything on technicalities and even quantity takeoff and other thing to guide, to make sure that there's project compliance. Supporting Opige was engineer Jude Wider, also one of our engineers from the head office that were all tasked to be on site to support the team. So basically that is how. So we realized that for project to be implemented successfully, really you need to have, there are those other key aspects, not this thing of tying the reinforcement. No. How do you communicate to the stakeholders? How do you manage stakeholders? There's management, there is communication, there are challenges that you have to handle. How do you coordinate? So engineering is not just a matter of going and tying reinforcement and casting concrete. You have to be a bit away, mentally kind of be out of the project and think how to run a project. So we appreciate that our team did manage the project very well. For us, we were doing spot checks. We go and come back. If any key stakeholder is going and they want to talk about the design aspect, we are there. We come in and we talk about that, because the RE and his team are more into implementation, and so that's how we also frequented the site. So this is the minister came and we took him around. From there we went. So this is now the concrete. I think this was the same. This was the first part of the concrete cast that day, and it was really hardening. The most unique part here was that this concrete, after 7 days, the 7-day strain was already reading almost 38. So it means that they never did mix design to compromise on the specified strength. Normally when you have a concrete of class 40, which is because C32/40 in Eurocode is this is cylinder strength, and this is the compressive strength or cube strength. Now this one you have to add at least about 8. So the target strength is about 48. So you cannot get anything less than 40. If you get anything less than 40, that means there's a problem with the mixed design. So that is what you need. But thank God these guys, they did not waste time on some of the things. They had to manage it. So the concrete grade is actually, when I talk to the deputy resident engineer, is above 40, minimum 40. It's going up. So this is the approach slab. This time the approach slab is the slab always constructed for transition. There are two types. You either have it at least 0.6 meter below the road approach, or you flush it with the deck. So that when you are coming, normally when you flush with the deck, it's very easy, because you just come and you get onto the approach slab and you transit into the bridge, and then you transit into the bridge with ease, and you don't realize. The only challenge comes in if it starts deforming under it, so it becomes difficult to notice. But with the reinforcement you have put, even if there are gaps down, this reinforcement helps it to act as a structural. So this is now the changes that they modified that let the approach slab be at the same level with the bridge. So once tomorrow they do, the only change, the only relation will be when you get into the expansion joint, you feel a bump, slight bump as you are crossing, but it will be same level. So this was the construction being done by the team. Most of this work actually 100% basically locally done. These people knew what they were doing. All they needed was a good design and resource mobilization and support. These are some of the things that people do in the kitchen. Designers are always never recognized because people want to see the blocks, machines, concrete being done on site. That's the engineering in the minds of a layman. But when you come in and ask, what is this? They will ask you, what is this? This is the 3D, this is the model. It is from this model that you will assess and have confidence that let's go ahead and do ABCD. Without sitting down and thinking through all this, you will be working like you are swimming in a dirty water. They tell you there are crocodiles and you cannot see. You just jump into the water which you don't even know what's in the at the bottom. So this is where your model, you begin to understand this bridge lifts at this point, it is facing up, this one faces up, this goes down. Therefore, the balls that you see there near the bearings are not merely for bearings. They are there to also hold this structure in place. If these balls give way and you have tracks here, then there will be disaster. That is something that people need to know. So many things happen, but very few pay attention. So the consultant also did this one we did ourselves. Myself, I did this thing, and the consultant also had their own. Now the first thing they were doing was to model it as a composite. But when demolition happened and we discovered, then they had to change the approach. So now you can see down here. This is now when you have. This is how this is what it is. This is the Karuma Bridge, ladies and gentlemen. If there are issues with this thing here, then you're going to have problems. This one and that one. We have put this deck up, but this deck is for rideability. It's for you to cross, to allow the tires to go. But the strength is important to have this to be. So if the contractor is going to continue working on this one until every member which is defected is resolved. That is now why they were saying, you have seen the scaffolding on the site and the rest, so please take note that all this will be checked. So this is the structural steel. When they removed the deck slab, these were exposed. So you have this main girders, and you have the two stringers. These are the steel girder. So the part that cracked and you were seeing when there was explanation is around here. The part that had vibration of bearings were this side. So this is what I would call it the naked deck system if you remove the concrete flesh. This is what it is. And this one, there should be no mistake here. That's why they were cutting carefully not to cut any of this part, because this is what the bridge is all about. This is an AutoCAD drawing as built information based on site measurement. Of course, towards the end, it's not uniform like this. Towards the end, because of super elevation, it becomes thicker and become narrow. So thicker this side, thinner this side to the 300. That one side goes slightly more than 300, the other side comes slightly to 300. So that is the super elevated section. This is typical. So this is the middle part, 30 meters, where you have within the expansion joint. So this is the typical deck detail showing existing gut rails, deck slab replaced, steel plate girders, stringers, cross frames, and bearing details. So this is what an abutment and pier support system. Then this is the scaffolding design. This is the formwork designed not to allow any current twists or poles to go in water. So these girders are strong enough to bear the weight of construction load, wet concrete, formwork itself, and any extra stuff. That is why it is. That's why you find it is robust, 2.5 meter deep. So this is the formwork which was done with a few modifications by the contractor. We have done it to make sure it has a guardrail here to take care of safety. But the contractor make it on a slightly above, and they just work from the inside. So here it would allow even guys to work from here. So I think maybe cost aspect and other thing, they did not do that. But still they managed to do something similar, which it was refined. So this is the formwork. These are interior. All these are still inside. They're going to go in and remove these ones here. They made this one here, the scaffold formwork here, bearing on these cross frames. Okay. And exactly, you can see this is the formwork they were trying to make here, which when you look at this one up and this that one, so yeah, there's some similarity here. But for them, they dodge this part here. They require some extra stuff. Yeah, so that is the formwork. This is now on the 18th when the contractor started on the asphalt concrete. And what they did here, they had to first do the waterproofing properly, do the priming, tough coat, and then they apply. So that is what is happening. What happened on the 18th? They did that, and then this is now what they handled. This is now what was done. By 19th, by 20th, it was ready. It is also marked already. By yesterday it was marked, but I didn't capture here. So at the commissioning date, this is now the crowd loading. Normally we talk about crowd loading, it has happened here. So the bridge had to experience, but because of the conservativeness of this bridge, the issue of the vibration effect and resonance, it doesn't apply here. You don't expect a 16-meter span with a 2.5 meter or 3 meter deep girder to start oscillating. No, it happened in cable stayed and suspension bridges and footbridges. Footbridges are more sensitive to resonance, not this kind of steel composite bridges. That is something. So this is the crowd loading that happened on the bridge on that day. Yeah, so this was when the truck started using the bridge. After the mission, I walked back to the bridge to see, and I found actually, you see, bridges in Africa here do not experience flooding traffic like in the Western world. So you can see now these are basically one line going. So even if you design to the highest traffic load, axle load, you use maybe 45 HB, unit HB, or you're using SV 190, during service, that load you have used is not being felt by the bridge. That is why sometimes the bridge should be kept in shape and form, but the capacity-wise, people should not worry a lot. What we need to take care of is let water do not underscore the abutment, let water do not affect the foundation. If we can take care of the support system, a bridge can work for as long as you can maintain, because the kind of load we use for design is not the actual load being simulated in real sense. So very, very important. So opening limiting use of the bridge to heavy traffic until mid-February. Opening a newly cast bridge deck to traffic requires careful consideration of the curing time and the condition of the concrete. Here are some key points to consider. Curing time. Concrete typically requires minimum curing of 28 days to achieve sufficient strength and durability. But reaction continues. This is what I'm telling you. After 28, you have the healing process. The pores get closed and other things. So that is very important. You don't need to open your middle to quite a number of traffic. Even the volume of traffic matters a lot. You need to allow. So if you see up how traffic is moving, it is more gentle, a more careful movement, and the speed limit is 20 kilometers per hour. That will not have effect on the bridge. All we need is to make that. So opening the bridge to light traffic is generally acceptable, provided the concrete has reached adequate strength. Light traffic typically exerts less stress on the bridge deck, allowing it to continue curing and doing that. So if you look at this behavior, definitely you should not. Even a 14-day strength, the concrete can be used because there is discipline, but Of course, when the heavy traffic guy is flying to DR Congo and South Sudan start flying, that's when problems come in. So basically, that is what. So this is a small frame model to understand the stress distribution on the bridge. I just did a quick model with this deck system and loaded everything. But the two stringers, this is the outer one. The idea was to see what would be the strength. So when this is the loading, using I think this is LM1. This is now Eurocode loading. Then later on, I also realized the Eurocode tend to be conservative, and we need to relate to British standard. Since it was also designed and constructed under British standard, sometimes it's good to do the checks using that. But all in all, is to just check for comfort. So when you do the loading, then you begin to see the behavior. This is solid stresses. Now this one, you're not modeling as plate. You are trying to look finite element to look at the stress distribution. When you have a load here, you have a load there, what happens? So the rate gives you higher stresses, and then it tends to degenerate into up to the blue. So these are things that you need. Now the stress generated and the compressed stresses and the rest of it, you relate. You realize that the stress development increases with the duration of curing and then being in service. So now you find, if you look at all these patterns, this is where you have the girders, this is where you have the plate girder, then this area and that area is where you have the stringers. So it gives you some of the stress variation here. You have, like, you see, like 13.9, and then the list here is about 5 point something. So some of this stress generation help you to understand and then follow what is happening to the concrete section when you load it. This is not the model you use for the design of plates. This is on a finite element, just for you to be able to appreciate the behavior on a typical section episode happening. Even on this the stiffeners, the bearing stiffeners here, these are intermediate stiffeners. You can actually see the stress generated on the plate girders and the rest of it. You can actually understand in detail when you try to do that. So briefly, this is a quick check that was done, but detailed model, detailed analysis that we have been using to give us comfort and follow this bridge is basically following this model here. It is this side that takes you, and then you do what they call reduce sections of these members. So these plate girders, because of some part of which have already corroded, you don't design it as though it is a new member from. You're supposed to do what they call load rating, do other things, but you can also still do a design check, because after changing the entire deck system, now you load the structure, but with reduced section capacity. If it is a 20 millimeters, you can actually look at if you can see maybe 4 millimeters already been corroded, and you're able to do a lower section, and then you rerun the software. You find that actually this section can go up to about even 8 millimeter thick section can actually yield good results. But when you look at the robustness, you look at the redundancy members, and you really appreciate that some design actually need to take this form, because even if we remove the stringers here, and these are cross frames are at 3 meters, you can remove and keep them at 6 meters, because these cross frames actually are supposed to be able to stabilize for lateral torsional buckling during construction. Once this concrete is stabilized, unfortunately, it is actually now I see, because it is not composite, therefore the whole frame need to be one. So then you place the decks up, then it works. But if it was composite, then you don't need so many of this stuff. So we have been trying to follow this bridge using some of these models, and then trying to look at the current loading condition, the temperature, even other things to guide. Right up from bearing, even when they're replacing, we could actually say, okay, when you're placing loads here and you're placing loads there, what would be the implication here and there? But the contractor, in his own wisdom, he did not follow even some of the things. Instead of removing in pattern, he just decided to remove the thing. In 1 or 2 days, the whole thing is removed. During casting, you say, okay, cast up to this joint, then cast up that joint, then cast the middle one, or start with the middle one. He comes and says, no, me, I'm doing everything at once. So in a way, you realize that sometimes what you design is not taken care, no, it's not taken verbatim by the contractor. Contractor with capacity, they have their own way of risk-taking. So those are some of the things that we learned. So, in a nutshell, the repair of Karuma Bridge has its genesis right way back in 2009 with a rehabilitation taken or done in 2012. The design for replacement of this bridge has its genesis in 2012 with the design report ready by 2014, reviewed in 2016. Because of lack of funds, the construction of the new bridge did not happen. That's why this bridge continues to suffer the way it is suffering, because we did not construct it one due to lack of funds. But now again, Japan government has expressed interest, and they're doing their preparatory studies to see how best they can fund the construction of the bridge, a new one, which tentatively is to commence construction in 2026, still 2 years from now. So looking at this old bridge, we can't leave it the way it is. It has to be repaired. We have to continue monitoring, and that is why you see this decision was made. At least this bridge can work for at least some 10 years to come and more, with close monitoring and attention it deserves. So that is something that we need to appreciate. One thing we learned here is that teamwork is very important. Procurement is key. Leadership is important. Communication, stakeholder management. Stakeholder management is a project management. That is something personally I have learned. If you manage your project well, you have managed stakeholders well. And the testimony is the Karuma Bridge. It has been handled very well, communication done well, the contractor did their thing, everybody had interest, and it was delivered. And the remaining part will also be delivered. So I think these are things that we continue to learn. Risk management is very important. As much as we fought hard with the contractors in areas of safety, just on that communication alone gave them the caution to take not to get any fatality. The constant communication on almost a daily basis from all the corners, be it administration, be it the media, be it from our side, even recording our voices, taking it the other side for them to follow, it in a way manage this project to the successful end. So these are some of the things that we need to learn, that project management is actually stakeholder management, is actually risk management, is actually communication management, is actually challenges to be handled. I know payment has not been to the dot, the contractor suffered, but because some of these companies are big enough, can mobilize resources, that is how we happen to see this project through. But payments always have remained a challenge to many players in the industry. It affects resource mobilization. With resource mobilization is on the critical path to deliver project. So Karuma Bridge is a testimony of good communication skill, good stakeholder management, proper risk management, proper communication, and leadership from different players. So my last word is managing an old structure is also the same as managing an old human being. the way we take ourselves, the way we manage our health, the frequency to the hospital, to the health center, wellness check is the same that need to be adopted and applied to the infrastructure we have. So the longevity depends on how regular, how timely you inspect, intervene, and sustain that. So I think this is something that we can share. It is an bridge management, which many of you, those who are willing or wishing to do bridge management course, you will learn that it is very important that inspections, maintenance help us to give the longevity each bridge desires. Thank you so much. Have a good day.